In this example, we're simply going to try to solidify the relationship between the exponents and the radicals. So in part A through F, we're going to be taking 1, 2, 3, 4, 5, and 6 respectively, raised to the third power. 1 to the third, 1 times 1 times 1, equals 1 in part A. In part B, 2 to the third equals 8, because 2 times 2 times 2 is 8. In part C, 3 to the third power is 27, because 3 times 3 is 9, multiplied by 1 more 3 is 27. In part D, 4 to the third, 4 times 4 times 4 is 64. In part E, 5 to the third, 5 times 5 times 5 is 125. And 6 to the third, 6 times 6 times 6 is 216. Now in part G through L, we're going to reverse the statement. We're going to take the same 6 statements that we have up above, but rewrite them as radical statements. Because 1 to the third is 1, then in part G, the third root of 1 equals 1. Now 1 is kind of a funny number because if you raise 1 to any power, you always get 1, and so therefore basically any nth root of 1 will still equal 1. But in part H, the third root of 8, well, we know from part B that 2 to the third equals 8, so therefore in part H, the third root of 8 is 2. In part I, the third root of 27 equals 3. We know this based on our answers from part C, that 3 to the third power is 27. In part J, the third root of 64 is 4. Again, because we know from part D, 4 to the third is 64. In part K, the third root of 125 is 5. And in part L, the third root of 216 is 6. The idea in this example, again, is to simply recognize the relationship between third powers and third roots. This would be the same relationship between fourth powers and fourth roots, fifth powers and fifth roots, and nth powers and nth roots. While some of these values may be unfamiliar to you now, things such as the third root of 125 is 5, or the third root of 27 is 3, you will start to see these in enough examples that you simply start to remember these.